2-3 Conditional probability and independent events. Consider the stuff of some company. A randomly selected employee can be characterized by two variables, for example, a gender and a work position, and we can create a table where the rows are used for the type of position of a randomly selected person, and the columns are used for the gender of this person. For example, there are 8 male and 3 female persons, each in a managerial position, 31 male and 13 female employees in professional positions, 52 and 17 in technical, and 9 and 22 in clerical. First, consider marginal, union, and joint probabilities. There are 6 marginal probabilities, 2 of being a male or a female, and 4 of being in managerial, professional, technical, or clerical positions. These probabilities are called marginal because the nominators for their calculation are the numbers at the margin of the table: 100 over 155, 55 over 155, 11 over 155, 44 over 155, 69 over 155, and 31 over 155. Union probabilities are related to the union of a row and column properties. For example, the probability of being a female or having a managerial position is 8 plus 3 plus 13, plus 17, plus 22 over 155. Joint probabilities are related to the intersection of a row and column properties. For example, the probability of being a male in a professional position is 31 over 155. The conditional probability is the probability of event A given that another event B is already happened. So, the conditional probability that a person is a male given it has a technical position is 52 over 52 plus 17. The probability that a person has a clerical position given it is a male is 9 over 100. For practicing purposes, use link to practice 2 in the description. The important thing to understand is the definition of the conditional probability. Definition: the probability of A given B equals the probability of the intersection of A and B over the probability of B. In other words, subset B represents a new sample space, and intersection A and B represents subset A in this new sample space. For example, it is known that the selected card has a red color. So, event B had happened. Additionally, you receive information that this card is a queen. So event A also happened. You can calculate the conditional probability as probability of the intersection of A and B, which is 2 over 52, divided by probability of B, which is 26 over 52. The result is 1 over 13. You could get the same result by using the areas, not probabilities. The area of intersection is 2 cards. The area of B is 26 cards. So the answer is 1 over 13. To illustrate the definition of the conditional probability, we can use the Venn diagram, with intersections of rectangles. However, the shape of the space and the events can be arbitrary, not necessarily a rectangle. The next important definition is definition of independent events. If the probability of A is equal to the probability of A given B, then A and B are called independent events. For example, let Q be the event that the randomly selected card is a queen, and R, that it is a red card, diamond or hearts. Then the probability of Q is 4 over 52, or 1 over 13, and the probability of Q given R is 2 over 26 or also 1 over 13, as we already saw in another example. So, Q and R are independent events. On the other hand, if A is the event that the randomly selected card is an ace, then A and Q are mutually exclusive and the probability of A given Q is 0, which is not equal to the probability of A, which is 1 over 13. So, events A and Q are not independent. The next example is the rolling of 2 dices. A is an event of having the sum greater than 9, B, that the first dice shows 5, C, shows 4, D, shows 3. It is interesting to note that B and A are dependent, C and A are independent, and D and A are mutually exclusive. In real life it is sometimes difficult to understand, If events are dependent or independent, consider the problem about a CEO. Some days the CEO holds meetings, and some days the CEO wears black shoes. How would you most likely classify these events? The answer in the textbook is independent. However, according to the dress code, the CEO likely wears black shoes to meetings, making the probability of wearing blue shoes on meeting days lower than on other days. This is the definition of dependent events.